Image NRAOAUINSFD Berry August's landmark observation of two colliding neutron stars was incredible for its immediate impact on astronomy. It answered questions, like, where did the universe's gold come from, and, how fast is the universe expanding? But it left behind mysteries, too. Like, what the hell is going on with those gamma rays? Even with the first announcement, scientists wondered why the collision's gamma rays looked weaker than expected. They surmised that the collision released collimated jets of particles, and we just weren't in the line of fire. But a few new papers have released further data on the collision's radio waves and X-rays, and demonstrate that the story probably isn't as cute and dreary as that. On August 17, observatories across the world spotted GW170817, the result of two colliding stars, each a little heavier than the Sun but only the size of a small city. They emitted gravitational waves, tiny ripples in space-time, alongside all sorts of light, including infrared and ultraviolet, visible light, X-rays, gamma rays, and radio waves. It was immediately obvious that the gamma-ray signature was not from a jet of particles pointed directly at the Earth. Maybe it was a jet pointed elsewhere, or something more complex than that. Astronomy has entered a new era, one where light and gravity both play a role in understanding. Read more. Read. But today, an international team is now reporting a brightening of GW170817's radio waves over time in the journal Nature. A second team recently put a paper on the arXiv, the physics preprint server, demonstrating the same brightening in the X-rays. Clearly something strange is occurring. The radio wave team felt their observations suggested that some sort of wide cocoon, a cone of matter, is choking the jet. The result would instead be a wide outflow of slower particles, and could potentially produce the radio and gamma-ray emissions that they observed. Image NRAOAUINSFD. Berry. But others aren't convinced by the cocoon interpretation. What if there really is some nearly light-speed jet of matter shooting out in a different direction, but with a much more complex structure of particles and speeds? The tension is between whether or not you can uniquely explain the observations using this cocoony thing, or whether you can still explain the observation just with a jet with more complexity built into the physics. Darrell Haggard, assistant professor of physics at McGill University who worked on the X-ray brightening paper, told Gizmodo. That is completely unresolved. Haggard was still extremely impressed with the data provided by the radio wave observers. The paper is really awesome, she said. There's more complicated structure happening in the outflow, causing some of the emission to get brighter where we expect it to get fainter. It teaches us all sorts of things that we're struggling and working to understand, but that's just astrophysics for you. You can't just perform an experiment to understand what happens. This is the name of the game in science, said Haggard. We observe our system and back-engineer what's going on. This is the first step in understanding what the observations show us. Nature.